Welcome everyone to this February event 26, and we are very happy to have Priyanka Schnell join us today, and we will tell a bit more about this new joiner. So today we are going to talk about from data to decisions using digital twins for smarter maintenance. Thank you, Priyanka. Okay, a little disclaimer. This talk is recorded and will be posted on YouTube at our youtube.com/@ourladiesroom. Please feel free to turn off your cameras if you don't want to be recorded. And we do this to ensure a safe, inclusive, and harassment-free space, which is our priority. We are committed to promoting a respectful environment where everyone feels welcome to learn, connect, and grow. So please remember that you agreed to our code of conduct. You can read more at ourladies.org/COC. And you can use the chat or raise your hand for any question. And please, as I said, feel free to say hello in the chat and to introduce yourself, where you're from. That would be nice to know each other. So there is this nice tool, which is Notebook LM from Google, which is a great tool. We were discussing this with Priyanka as well. So I've just loaded a bit of our information, such as websites, such as a GitHub repository and other things. And so I've asked for summaries of our Meetup account, all the tutorials that we recorded, people that joined us, and so on and so forth. And so he releases nice, very insightful posters. As you can see, this is one. And a bit about us. Already Strom, it's a community for particular for R and data science, but we do not deny that we love other languages as well, such as Python. What we do, who we are and what we do. We are a group of organizers, we are volunteers that share this common interest, which is data science, data analytics, and things. We welcome all levels, all proficiency levels in R, from beginners to advanced. We do tutorials of different levels. Our community grown a lot during the last 3 years. So we have now over 2,500 members. And so what we do is organizing workshop, develop our skills, and networking. This is something that we love do too much. So this is a nice space. We can say we are free, we are safe, no cost, no fees, and everything is open access. And so more insights about numbers, Our Ladies Rome in numbers. The highest number of reservation was with an event with Nicola Renni about data visualization. We reached about 416 attendees. Obviously, we have a limit of 100, but no one. We obviously welcome everyone, because then we post the recording on YouTube, so you can watch back the tutorial at your earliest convenience. We have we had organized one event a month for the last 3 years, and actually grown nicely along the way. Interesting are events about data visualization, as I said, health analytics, and even if the Git and GitHub reached a nice audience. So what we are focused on lately was health analytics, machine learning, and what we like most is data visualization. So our curriculum spans from the full data stack, from data cleaning, modeling, and production. Here is our pulse of the community, consistent growth and engagement. Reservations, as you can see, the trend of the reservation from 2023 to 2025. We had a nice peaks. And so it looks like a real recurring engagement. So thank you very much to everyone who joined us and continue doing it, and keep an eye on it because we do more. And so we don't have it only GitHub, we have LinkedIn, we have various social networks, and even on LinkedIn we have reached about 8,000 followers. And so our community is growing nicely. Who we are? So we are amplifying voices, bridging gaps, improving our skills with a collaborative learning where experts mentor the next generation of our users. Me, it's this one here. This is me, Federica Gazzelloni. Priyanka, which is just joined us. I don't know if you would like to just tell a bit about you, or just very briefly, because I imagine that you will tell more later.
Yes, hi, this is me, Priyanka.
Okay, and Rafaela Ribeiro, which is the other organizer. So we are powered by open source leaders such as our consortium and the Linux Foundation. So these are our sponsors. Here is our website. You can scan the QR code. We have there you'll find all our social networks and things. So please follow us and keep an eye on our YouTube channel for the recording and more events like this. Thank you.
So a little about me, like I've been a part of Airbus digital transformation journey for around almost 8 years, living here in Hamburg, Finkenwerder, and experienced basically the whole industry level, how data has been like leveraged to build digital twin across like the design, then the manufacturing, and have built platform for real-time exchanges. So 8 years have shown me like a lot of the complexities that's involved working with different nationalities, different systems, and every time things compliance have like changed, how we have adjusted with the regulations and so on. But I'm happy that I learned quite a lot from that. Yeah, so today I wanted to take a scenario basically out of all of the whole digital transformation, where I would like to cover the application of condition-based maintenance on production equipment. So condition-based maintenance would basically result in less cost and maintenance practices. Yeah. By the way, if there are any questions in between or after, you're more than welcome. I'm happy to answer. Right, so going back a little bit about the traditional maintenance. So when we have like an equipment in the assembly line, normally we would have fixed a date, and on that we would have all the repairs and all the maintenance done. But with that, we were having a significant loss, or we detected a loss, and we had then a deep dive and understanding how could we improve the situation better. All right. Yes, so what you're seeing here is basically a fuselage that where in the assembly line of A321 of the airplane, where basically the robots are drilling the holes, which will later be riveted. So here, the idea is, or the problem started was, each of these drills that's happening in there, if it the bits are like scratched or snaps in the mid process, then it's like impacting the whole fuselage structure, because it's causing then burrs and delamination, we call it. So this becomes then a non-conformity issue for airplane processes, and it carries like a potential risk in terms of quality, cost, and time, majorly impacting the processes and capacity. So this is the problem, and yeah, we do risk almost around 150,000 euro, and the goal with the digital twin was to detect the failure before it happens. Yeah, and I can share the next slide. Yeah. So as I was saying earlier, that time-based fixed maintenance was governing basically the life cycles. And with digital transformation ongoing, different cost-saving methods were explored, which was then done with a thorough gap analysis of the process, tools, resources, and it was noticed that with this kind of fixed maintenance, yearly maintenance, 30% of the bits were replaced early. And there is also like 5% were failing prematurely because the materials were different. So to solve this, or say we were doing previously for every 50 holes, we were changing immediately the bits, but that was a waste. So to solve this, we started collecting the sensor data. And what we did is, instead of scrapping the bits after 50 holes, we started taking out from the sensor the temperature rise, the spikes. So as the tools were wearing out more, there were frictions and causing the temperature to rise. And this is the equation, let's say, which was our pivotal equation to determine the balance and detect the rise in the spike, temperature spike. Yeah. Right. So when we had all the sensor data, it enters, it's basically then becomes like IoT data. And it's a whole complex system in my perspective, where we had to balance out the data storage system, then make it real time, have the data, process them first, which we worked on, and then maintain the data quality and build a real-time digital twin, injecting like every time after building like a base model, every time injecting it with the real-time data over a period of time. Then it became like the whole model, which would give us the earlier indication of the failure. So yeah, that was quite an interesting project. Yeah. And so what we did is here, keeping the condition-based maintenance, we tried to detect the point of failure. So this PF interval, it's a very common practice where long-term analysis is done, and anomaly detection was the main aspect of it. So the intention was mainly to detect the failure faults earlier. And so if we move like the point of potential failure to the left, it means that we have done it good and we could prevent the failure. One thing we had to take care of, this regime normalization, we called it, is separate training the data or the model for aluminium and titanium to not have the noise or mix up of the signals, because each materials, when it was coming in contact with the drills, had different torque or different vibrations and different data sets. So that we had to do. And then we could like set up the healthy base and detect the anomaly. And at some point when it was mature enough, then it could alert us like, okay, this is where you're going to have failure. Another point was, we noticed there are a lot of, in reality, it's a lot of noise that occurs. each spike is not automatically a failure. So we had to define like what kind of amount of spikes, like 6 to 12 maybe, is acceptable. And beyond that, we should start looking whether to alert maintenance or not. Yeah. And yes, so doing as such, I try to give as best as possible from my perspective a high level view of the whole system. I've not included here the whole system design and the architectures, but I want to highlight that the payoff over time was that the system went from reactive to proactive. So there's been an increase of the lead time. We could cut off costs, and it helped us then in the ramp up delivery. So as you can see, the tool utilization with the 2 hours of lead time at point P, and the scrap event like went down because we could save. These are the potential preventive failure. So then it goes for the business logic that, all right, it's been done. One point I want to mention here is that today for the demo, I could not use the real data due to lack of it, industrial data, and these are figures that's plausible. So yeah, I can try to open now quickly the demo in Google Colab, where I can show the digital twin simulator. So here you can see that we are using the libraries for mainly for the data, the ML learning, and the visualization of it. So,
and then we have this for modeling.
exactly, yes.
So we have this things for data, for
Yes,
visualization, and for modelings.
right.
Yeah. Then in your warnings, and then we go to digital twin engine. So what is this class? So we set like a message. What is this things in particular?
Yeah, so this was for me to like put some notes, definitely like how we are basically setting up the normalization. So we are basically trying to say that we want to have for aluminium and titanium, two different material, two digital twin baseline. And we wanted to discuss that we want to train the ML with the features, physics informed features, that it's a healthy state, and train it so that it can detect the point P, which was the point of the failure.
Okay. So
Yeah.
Okay. Then, so we define.
Yeah. And this is,
Yeah.
yeah, so here it's what you can see is we are defining like the sample. So as I said, like I did not had the actual original data, and I had to create like the sample data with where you can see which 6 of 12 holes. It's mainly the definition for me that after what the particular failures is acceptable or not, together with the number of holes that it could have.
Okay, so you're starting with 220. What are these are the number of holes. And then
Yeah.
samples per hole is 12.
Yes. So,
Okay. For number of points of potential failure and the functional failure. So you have these other two parameters.
correct. So here I'm.
Yeah.
Yeah.
So you have basically building up a data frame. Is a data frame. This is a data frame, yeah, with all information about number of holes, the samples per hole, and the potential failure and the functional failure. Then you have the drill diameters and the sample, and again, sample. So I don't think are you gonna use everything in the model?
I can walk through just the sections, maybe that's better. So in the first section, it's mainly the definition of the parameters, everything that was needed for detecting the data that it should have.
Mhm.
And if we are, then the idea, it's basically the architect of like how the feature-based modeling has been done.
Okay, so here you name the columns
Mm,
of the data frame, because set
right.
dot number of holes, you call it n holes. So you name the data frame. Can we see the output of this data?
Yes, I think if you go completely down, there is a dashboard that visualizes then the,
Okay.
yeah. So this is basically what is the interesting part for us was. So we trained the model in the aluminium and in titanium. So providing it with two baselines, and then we used the isolation anomaly method to detect like where the failure could occur.
Mm.
So and it was also then scaled, and here we can see like healthy, the red one is basically like the actually how it would have been like, and the blue one is, or the actual torque, this is when basically the heat gets higher, the sensor already detects it, and it's a pre-warning, like between point P to F is a pre-warning that okay, this is going to fail.
Mhm. Yes, sorry, Namidi, how do you pronounce your name? Sorry.
Priyanka?
No,
Awesome.
yeah,
Yeah, sorry.
sorry,
So yeah,
sorry.
hi. My name is Namdi. Namdi.
Namdi. Hi,
Yeah.
Namdi. Thank you very much for your question. Can you ask her yourself?
Yeah. So you mentioned isolation forest, and
Mm.
because it has the name forest, I was wondering if it's somewhat related to like a random forest, as in a decision based on decision trees. Because I've never used isolation forest before, but I've used random forest and I've used gradient boosting machines.
Um, Sorry, I didn't catch the question. If it's a decision tree based method?
Yes,
Yeah.
that's what I'm asking. It's based on decision trees. Okay. Okay. And does it work with percentiles? Is it like kind to, because I know you're doing this is about anomaly detection, so I just wanted to understand. Are you using percentiles and that sort of thing? Some 95th percentile or something like that?
Uh, yeah, like it's so I tried to answer from my perspective. We had like the base theorem at the base, like as a baseline, and then we separated the data into like sets of small chunks, and then we trained it in percentile. I don't know if that answers the question.
Okay. I think for me it's fine that it's based on decision trees and that you're making use of percentiles. Like I'm okay with that.
Okay.
Yeah.
Yeah, because I had the same question. What I was curious is what model did you use, in fact, and
Yeah.
So basically, we built this data frame, and then set some conditions,
Yes.
and then generate a new data frame, which ran a for loop. If the all is within the range, then
Exactly.
you were harnessed, and then again another for. So you do some various things, and then you apply formulas,
Correct.
check the noise if it's normal, if it's a random normal distributed noise. So can you help me finding the model?
Yeah.
Okay, we append all things.
I don't. Okay. Yes. Okay. No. So I how do I explain this one?
Train if forest per regime.
Correct. So these are the two different for the two different materials that we are using the regime normalization.
Isolation forest. Standard scalar.
This is when we scale the whole system.
Mhm.
Yeah.
What is this isolation forest though?
It's the model that we are using. It's separated from the random
Oh,
isolation.
there it is. There it is.
Okay.
Isolation forest, number of estimator, contamination, random state. Okay, is there an R function that makes this type of model, the isolation model?
Normally it should be because it's one of the standard practices, or how can I call them, like a framework or methodology. Is this correct if I say it? So it should be there. Yeah.
I know I know the random forest that runs with different type of engines.
Yes.
And so was wondering about this one.
Okay.
That is very, very interesting. Thank you. Thank you very much.
Okay. You can check. So it's, I mean, this is an unsupervised model. I don't know if we are talking.
I think it Isolation Forest. I just clicked the link in the chat. An introduction to isolation forests. And so set the seed. I recognize this language. Isolation forest. Library ISO 3. There you go. Thank you very much. Very helpful. Okay, I go back. Sorry about that. Go back to Colab. There we go. Okay. Sorry, I don't interrupt you anymore.
No, no worries at all. So yeah, so I divided the whole or the architectural framework is basically we defined the synthetic, in this case I would call it dummy data, because synthetic data would for me would be still some sort of sensor data, but not from the current machine. But yeah, we like check the degradation behavior in it, then provide this regime normalization for two sets, train the ML with the feature engineering before that, explaining it, and we check the outliers, and then finally we go to the decision, like teach it that when it should be deciding, maintenance decision and the scoring. So this
Okay.
is how It's one can say it's basically a simulator. If it is to plug into the real world with the real-time data exchange, it would have a lot more different aspects connecting for it.
Okay, we have nice information in the chat. I don't know if you can see it, but so this is Ricardo said the R package that implements isolation for this called ISO 3. ISO forests are usually used to detect anomalies such as outliers. And Namidi said, think of 3 different themes. Trying to spot weird insurance claims in a pile of normal ones. So isolation forests, random forests, and gradient boosting machines. Particular isolation forest is the team that asks, how quickly can I separate this claim from the rest using random yes or no questions? Okay. 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 So then it's gonna isolate the response that is not good or the response that is good. Which one of the two? The yes or not? If it gets separated in very few questions, it is probably unusual. If it gets anyway, my knowledge stops at random forest and gradient boosting machine. So I thank you again very much for giving me this information, which I'm going to have a look at later. This random forest is what I know best. And this is the team that asks, if I train lots of decision trees to predict an outcome, I already know, fraud or not, what do they vote? This is ChatGPT. That's this articulated thing. That's great. I don't have that clever ChatGPT though. So it's mainly supervised prediction. So we have decision trees. Okay, this is the very first starting point. Then we have random forest, which is a bunch of decision trees.
Yeah.
But here with isolation forest, it's a in between of having some of decision trees that splits between yes or not. And that should, again, follow some percentages, as Namidi said.
This probably, or it would be, I did not focus on the model.
Okay.
Yeah, the code is mainly to simulate a twin that could have, like, mainly to walk through how a physics informed with the features, how the whole digital twin is built up. So I must, yeah.
So usually isolation forest is usually used for anomaly detection without labels.
Okay, yeah. What would that imply? Like, in what are the cases that could be, like, how would I have, how it could have been done in the real data? How would it have been different? That's actually interesting to know.
This case, the model is using a matrix of numbers and dealing with numbers, splitting them between like yes or not, depending on some percentages decided by the parameters that has been set. While labels data, so you have specific vectors, so predictors with a name, and so each vector is treated as a vector and not as just as a singular number. And so the vector in itself might have some influence on the others more than a singular element of the vector.
Correct. Yeah.
So but gradient boosting is still more like advanced type of random forest. So this is nice things. Thank you very much. So
That's yeah. So yeah, like the XG gradient boosting model. Then there is the CAT model. Without the names, I know that many of my colleagues they use all of it to get a better envelope of the prediction. And in this case, usually we were doing it with also first defining the business logics translated into the rules for the decision. So that makes sense. So thank you. Yes, that's cool.
Yeah.
Yeah.
So, and then you finally evaluate. So you have run your model, set your parameter, run your model, and now you are evaluating where is this level of criticity of the word where the warning can arise, basically. I use a confusion matrix to see true and false, as you briefly mentioned. I said, just understood. True and false. I said, I know something about that, but I don't know what in this case is how to be treat the true and false things here. So, and I suppose it's this one.
Yeah, if it
Yeah.
is like the matrix that is being seen. So we did had like the business logics that were given on the real data, and it was then going for, yes, this matrix. If it is more, like then it's healthy. And if it is less, then we know that it's degrading and failure. So over time, it's anyway supposed to always degrade. But yeah.
Okay, so in this case, with this synthetic data, we have more degrading failure elements.
Yeah, right. Like in realistic cases, building a digital twin, we would have run like the whole data processing aspect of it, then standardize the unstructured data into structured data and build complete aspect and then train the model. But here, yes, it's I had to use I had to generate the data, and I call it dummy still. So yeah.
Okay, so this one is as well a nice plot that we can see with this matrix.
Mhm.
Okay, this is the dashboard that contains more than one figure. So
And
a list of plots here.
yeah.
Yeah, so we have another one, that a couple of two that don't tell anything yet. So just want to see, go back to this first one. So the confusion matrix here. And what we can also say that the actual values, so these are observed values of, they have more LT elements than degrading failures, but then the healthy.
What it is showing is basically like we give it a score in the matrix, like what amount of has been predicted and has degraded. So for example, if we take the 932, this is what was predicted and actually been degraded or failed. If it was predicted, let's say 28, which was predicted to be healthy, but it still failed. Was not correct, although it predicted that it's not working. And the actual data showed that it's still healthy. So this is the
Yes.
way this has been built to read the outcome.
Yes, and I mean,
Yeah, just wanted to ask what kind of, in terms of these predictions, so at what was the time interval between the prediction taking place and the actual happening? So we talk a month or months or day, you know.
That's a good question, actually. So, It was like almost around 500 or 600 like holes, which was taking the interval of 3 to 4 months before changing the bits. And maintenance was planned or scheduled yearly. Here, now we introduced
Okay.
sensor data, and it was monitored and observed, and it then overall it reduced 2 hours of lead time, thinking out loud. So yeah, maybe 9 months of the whole aspect, like the whole analysis after it ran, then it started giving. So at first it was to set up the whole model, train it,
Hmm.
and the outcome. So yeah.
Right. Okay.
Okay.
So basically, essentially, when you do the prediction, you're saying over the next 12 months,
Mhm.
how many of these bits are going to fail? You do a prediction, so that's kind of your prediction. And then at the end of the period, you then see, okay, this is how many we had at the start, this is how many has failed, this is how many hasn't failed. And then
Yeah,
you do your like a confusion matrix. That's
yes,
sort of right. Okay.
yeah. To kind of analyze that what has been set against the baseline and what's been predicted, if it's actually correct or not over the period of time. Yeah.
Mm.
Mhm. And you have a window here.
Yeah, so this is defined because normally if there were like a spike with the 6 spikes or to 12, it
Okay.
should have had to learn that like this is the tolerance zone, like we can accept like 6 to 12 spikes before we actually say train it that it's an alert.
Uh-huh. Okay. Is that this one?
Mm.
Okay. Okay. Yeah, sorry. Let's go to have a look at the next. So we have seen it, this one. So this is the twin baseline, basically.
Yeah.
So yeah, so you already said that, but I didn't catch that much. So I imagine that this is the twin because they are here matching each other and then they split, and when they split, something happened. So the failure or something.
Correct. So the red one is the twin baseline of how a healthy system or the healthy censored system should work. And the blue one is basically the actual system when it starts to wear off and shows like, okay, at point P, the sensor data notices the spikes, and this is where it starts giving the warning that like it's going to fail. So P to F is basically our zone of showing that in this interval is already saying that it's predicting that the failure would happen for the bits.
Okay. Maybe you should have something here, like the x-axis or something.
This is true. I'm not very,
Uh,
I haven't
Maybe.
visualized this very well. I just thought to have brought the
But I
concept.
think this is the value, no? It's
Yes.
2,414. What is 14? Yeah, because this is this point here shows at least what is the x values.
Yeah. So of the actual torque that it would start with. So yeah.
Around 2014. Okay, 200, 2000, 2014. Okay. So yeah. Mm, okay.
So yeah, like anything that was below like a zero, then we understood like, okay, this is the point where we should start being observant for maintenance to start. up till that point, then yeah, it was basically all right. Or it's still healthy, the baseline.
Okay, so this is
yeah, so the first graph is mainly showing like the divergence of the gap and wear trend. Like it's the trend that shows like where the wearing of the drill bits from the sensor data shows that it starts to happen. And second one is like the anomaly score. So,
okay, it's all one plot. Okay, so now I see anomaly score and persistent alert. I don't
cool.
see the purple line though.
Before,
Oh, okay, this one here.
yeah. So it's also then those are the points when it would then also have started alerting the system that like, okay, please go for maintenance. And so that's how the concept this is basically showing the proof of concept for the digital twin simulator.
Okay, so this is basically one plot. Because this is the dashboard. So this is the confusion matrix. And what is the code for the other plots? Plots, subplots,
One, two, yeah.
code scatter,
Yeah.
add trace. Oops, fiction. Okay, this is a scatter plot. I imagine scatter plot. I don't see the scatter plot. Oh, okay. 3 rows. Okay, this is the three plots. So this is the layouts. Make subplots, 3 rows and 1 column, and these are the 3 plots. So 1, 2, 3, 4.
This is then
Layout. Make point P.
that's one with the parameter.
This is I don't, because this is 2. Row 1 and row 1.
It's to show that the gap in wear. So you have the first one as the baseline and then the other one that goes away from it.
Okay. So this is the first one here with 2 lines. Such as in base R when you do the plot and then add a blinds. So add another plot on top of the other. Then there is this other trace. Anomaly score.
It's the
Yeah. So all used this test score and various like anomaly score, persistent alert.
it's defined year up before. Yep.
Okay. Is there a way to see this test score data frame?
These are dummy data, so it's been
Log present. Okay. So that's very interesting. What's happening if I do this? Can I just see what is it?
I'm also curious actually now, yes.
But yeah, how can I do to see it?
Okay, and then if you play like on the left up.
This already.
Yeah.
This runs all cells.
Or would you have liked only one particular cell?
Yeah, just this one.
I'm not sure that in here we can run only one, so it's
That's-
not defined so exactly. Yeah.
Okay, I'll play with that later. Thank you very
Okay.
much.
Pleasure.
Yeah, I don't know if you want to if you have anything else, if you want to go back at some point. So things, if there's any questions in the chat, I haven't checked.
Okay. Yeah, you can check.
Okay. Please feel free to unmute yourself and ask questions if there's any more like information that you like to gain from this session. Okay, this is a very fascinating topic. Okay, so this is a way to show how modeling applies in real world cases. So thank you very much.
Pleasure. I had, yeah, I hope I could spread a bit of like the insights on, yeah, business logic coming into how we had to, yeah, set up like the system or the model. Yeah.
And another question is does here machine learning things that like calibrating parameters autonomously?
Yes, so this is not calibrated. That's exactly also the point. In real world, it should have been, and it does. This is more in a prototype setup right now. So you're right. Yeah. I that was the question, right? Like
Yeah. Oh,
in within like the Airbus system or the facilities, we were connected with the cloud computing, and as well like the whole setup where it's this one is a part of only like we are concentrating here in this scenario only one piece of sensor data, but in actual real life there are a lot more data that's in real time getting exchanged. So the refinement, the calibration, the system load balancing, yeah, it's it was quite some time and procedures and process that had to be seen in the failure mode. So yeah.
great, quite interesting. So there is a question in the chat. Do you also use computer vision for the POC?
Computer vision is also done. So what we did was always like when we were developing the whole digital transformation project, separate each small things like this as fun, like experimentation in the development stage. And we did use computer vision for transferring the unstructured data into like or PDFs, emails, and everything to find a way. What we call today the agentic AI, we were building it back then to, yeah, like give it some semantic meaning and formulate it into our business system. So yes, painful time, but nice time for the proof of concept. Yes.
How do you use AI? How do you, so I imagine that you query AI, and then how much do you trust AI?
Well, now it's different. Like we do have different large language models like OpenAI and ChatGPTs with the APIs. So it's mainly, I think what was interesting for us was to use like, for example, Paddle OCR, the from the Hugging Face libraries, and the whole way of thinking. Like when we were getting just reading the data, it's just data, but how do we give the semantic meaning? So after giving it the semantic meaning and having to have taught, then we could connect it to the large language model to kind of automate or make some of the steps easier for it. I don't know if I answered your question exactly.
Yes, I imagine that you use it for like facilitating some steps, make it easier, steps that you mainly know how they should be and how they should behave. So you trust AI by using a model that you find, for example, on Hugging Face, which is very well like tested out. And then the intermediate steps are tested on. I think it's you using the sample cases and see if they work. What is the output, and then you put it on larger real data, larger amount of real data.
Correct. Yeah. So we had to work basically first like on the whole data processing aspect of the actual thing and then go for it. And for us, it was one of the main issues were the transformers. So how we were transforming the data, and it was connected back then to a whole lot of GPU usage. So that was making the whole everything very expensive. But other than that, it paid off at the very end. Now it's a lot more accessible, I would say. So we were working within the Google environment with GCP. So,
Okay. Thank you very much. Stop sharing.
yeah.
Yeah. So very interesting. Thank you. And I look forward to the use R for this code and see how it looks.